Hello there guys, and welcome back to another epic Inexorable video. In this video we're looking at finding the equation of a circle by completing the square. Isn't that kind of crazy? Completing the square, a topic from quadratics, is coming back to absolutely haunt us. Well, it's actually not that bad. So let's just consider something for a second, okay? If I was to give you something that's already had the square completed on it, so let me just make one up. Let's take, I don't know, x plus, let's do x plus 4 squared, and let's just go with that for a second, okay? If we were to expand that out, how do we do it? Well, we just use FOIL, and you can try this if you want, but I'm just gonna go ahead. Okay, that's essentially the expanded version, okay? That's what it looks like. Now, what's the relationship between that 4 and that 8? If you don't quite get what I mean by that, let's just look at another example. Let's take x plus 7 squared, and let's expand that one out, okay? Same thing. What's the relationship between the 7 and the 14? I'm asking the second number in the bracket, so the 4, the 7, whatever, being squared, and then the x term. Not the x squared term, not the constant, the x term. The 8, the 14. Let's do one more. The 9 and the 18. Hopefully you've seen it by now. In any situation, the x term is always double what ends up in the bracket when you complete the square on it. If you go backwards by completing the square, and we did this in the completing the square videos, we know we take half of, if this is ax squared plus bx plus c, we take half of the b term and we put it in. That's what we do in every situation, we do it all the time. So the question is, using that fact, we do know where that comes from. It comes from the formula for completing the square, which can be derived. That's fine. We know where that rule comes from, where that line of reasoning originates from. But what we haven't considered yet is how we can apply that to the equation of a circle. Because the equation of a circle, if you look at the formula for it, it kind of looks to be like in a sort of double completed the square situation. We've got some square here, some square here, and some square here. But this square is a constant. So what we can do very cleverly is we can go backwards and we can find the equation of a circle if it's not in this form, if it's been expanded, quite easily actually. So let's actually have an example and I'll tell you all about what I'm talking about. Okay guys, we've got an example over here. We want to find the radius and centre of the circle with the equation x squared plus y squared minus 2x plus 8y equals 0. Notice that is not in the proper form of the equation of a circle, which looks like that. It's not particularly helpful. This is the sort of thing that you can get in an exam question. They will just give you a bunch of nonsense like this, and they'll just say, find the centre. You might say, how do I do that? Because it's like we've got this term and this term. How do I? Fear not. We use completing the square. Now you can cheat a little bit, and then if you're not sure whether you got it right, you can go back and check, but this is the way that you do it. You make, every question, you make the previous observation that we made. Essentially, if you have some bracket, let's say, I don't know, for instance, I know x minus 1 squared. If you expand this out, you get this, okay? Just trust me. If you don't trust me, do it, and you will get it. The rule, the pattern is, whatever this is, you double it, and you put an x in front of it. That's the x term. And then you just square this. This is minus 1, you square it, that's positive 1, goes there. That's it. It's always going to be, if this is a 1x, you always get an x squared minus 2 lots of this plus the square of the next term. Boom, that's the pattern. That's why I was doing it so fast without even thinking. There's just a pattern. Now, what are we noticing, guys? X squared minus 2x. X squared, forget the rest of it, minus 2x. Which means actually hiding inside this equation is this. It's hiding, it's hidden. So, by using some rearranging ability, if we take 1 away from both sides, we get x minus 1 squared minus 1 equals x squared minus 2x. Don't we? Because we just took 1 away from both sides. So what you need to do, basically, if you get this situation, look at the x, we'll do y in a minute, look at the x, stare at it, and go, I need to half that. Now that's a minus 2x, so you need to end up with minus 1. Expand it out, rearrange to get the constant on the other side, and now you've got 2 terms that are a part of this problem. You can replace the x squared minus 2x with this, and then we are 1 step closer to being in the correct form. So what I will do is I'll rub this off and I'll swap the orders round, so make it a bit easier. This is going to be x squared minus 2x plus y squared plus 8y. I didn't do anything other than swap these 2 terms round. I didn't actually do anything mathematically, just swap them around. Now it's easy to see these are terms here and these are terms here. We can just replace this guy with this. So instead of x squared minus 2x, we've just shown that this and this are the same thing. This and this, they're the same expression. So we're going to replace it. We're going to go x minus 1 squared minus 1. That is that. And then we're just going to add the rest. So plus y squared plus 8y equals 0. That was already there, as you can see. But look, now that looks like we're on the right track, right? There's our x minus a. Right, where is it? Right here. Boom. Okay. Let's just find the same thing, but for the y's. So let's just do that. What do we need to do, guys? We need to find half of the y value, which is 4. So, guys, we're going to consider, this time we're using y's, aren't we, because we have y's here. We're going to consider y plus 4 squared. And that, again, you can try this if you want mentally. It's this term times 2 and then an x in front of it, and then it's the 4 squared 16. That is it. Now, guys, what are we noticing? Are you seeing something again? Look at that. Right there, once again, it's concealed. It's now revealed itself. So we can just rearrange. Let's take 16 away from both sides. Let's move the constant. We get y plus 4, still squared, minus 16 equals y squared. Oh, sorry, that's supposed to be a y. Other than that, we're all right. Now, all we need to do now is we have y squared and it's still plus 8y, just like that. Y plus 4 squared minus 16 equals y squared plus 8y. The 16 was just moved onto the other side by subtracting it from both sides. Now, guys, once again, we've got an expression, y squared plus 8y is identical. We can even put an identical symbol in there. That just means identical too, if you're not familiar with that. Nothing fancy is going on, just saying they're identical. Is identical to this thing. So we can rewrite this guy up here. We get x minus 1 squared minus 1 plus y plus 4 squared minus 16 equals 0. Once again, guys, if we look at this row here, I'll circle this because I know we've got a lot of, or I'll box it, I should say, because I know we've got lots. Looking at this thing that I've just put a box around, we're looking really on our way. Then, guys, we just need to gather up the constants and put them onto the other side. So there's a -1 here and a -16. Those things add up to make -17. So if we add 17 to both sides, we end up with x minus 1 squared plus y plus 4 squared equals 17. Again, you know if you're on the right track if this is positive. This should always be positive because this is r squared. R squared has to be positive, hasn't it? Because you can't square something and it be negative if it's a real number. So that is the equation. Now it's not asking us for the equation, it's asking for the radius and centre. So this is in the form x minus a squared plus y minus b squared. There's a plus sign there though, which means this must be a minus 4. So the centre is 1 minus 4, because this is in the form y minus 4, y plus 4. Hope that bit makes sense. That's the centre. Boom, done. The radius, so I'll say C for centre. The radius squared is 17, which means the radius on its own is just the square root of 17. Boom, they're the answers. So the takeaway from this video is that you can use the method of completing the square, very strangely, for circles. And you can find the equation of a circle using completing the square. This is the way that you do it. You essentially just observe the x and the y terms that have just x's and y's in front of them. You observe essentially that if you were to hypothetically halve those and put them in brackets, complete the square on them, then they would reappear. And then if you carry out this expanding of your completed the square version, you end up with essentially an expression like this. You can then choose, okay, I see a y squared plus 8y in the original equation. There it is. I will then replace it with something that's much easier. And then you're essentially going to eventually get to this form. Once you get to this form, it's much easier to see what the centre of the circle is. Much, much easier. As with the radius as well, it's far easier. And that is essentially, guys, how it is done. Thank you so much for watching. I highly appreciate it. And I'll see you in the next video. Cheers.